This is the asynchronous recording for Geometry 1A, Unit 5. This week we're going to discuss proving that the area of a triangle is 1/2 times the product of two side lengths times the side of the included angle, and solve problems using this formula. I know that was a mouthful. Really, we're just going to be using a formula to help us identify area or some given quantity related to a triangle. This includes finding the area of an isosceles triangle given the base length and measure of an angle. Okay, let's get started. So, a refresher. If you remember, you've probably dipped into some trigonometry work before in your math education. When we have a right triangle and we have some angle, this angle is named theta. Theta is just a Greek letter. It could just have easily been named x or angle A or something like that. So I have this angle theta. There is something called the sine of that angle, sine theta, which is equal to the ratio of the length of the opposite side to the hypotenuse. Okay, now when I say opposite, it's side opposite that angle. So I've got angle theta. The side opposite would be this guy over here, and we can always identify it as the side that does not form the angle. So you can see this side of the triangle and that side of the triangle intersect at this point and form angle theta. So the opposite side of the triangle is the one that does not is not one of the included sides of the angle. Okay, so if I had a triangle that looked like this, and this is my angle theta right there, this would be the opposite side, again, for the same reason. So an angle includes two sides of the triangle. The opposite side of that angle is the one that it does not include. It's the third side of the triangle. Now, there are other properties such as cosine, tangent, cosecant, secant, and cotangent. These are all important, but we're not going to focus on them today. This SOHCAHTOA is a mnemonic device, or in other words, a helpful memorization tool to help you remember how to find sine, cosine, and tangent. So this sound, SOHCAHTOA, helps you remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Okay, again, this applies to right triangles, excuse me. And again, for today, I really just want you to know how to find sine. Okay, so again, we would need to know the opposite, and then of course the hypotenuse, which is the longest side of the triangle, and it is opposite the right angle. Now, the adjacent is just the side that's not the opposite and not the hypotenuse. So for example, if this is our theta, we automatically know that this is the hypotenuse because it's the longest. This must be the opposite because it's the side that is not included in that angle, or that doesn't form that angle, which leaves this guy to be the adjacent. And remember, the word adjacent means next to, right? Your neighbor's house is adjacent to yours. It's next to yours. So again, sine is opposite over hypotenuse. Also useful to know what adjacent means, but we won't be calling on that information today. Okay. Another thing we are going to want to refresh ourselves on is the basic formula to find the area of a triangle. Now we know that area is 1/2 of base times height, and this is pretty a straightforward calculation when we have a triangle like a right triangle, for example, where maybe they tell you that the base is 5 and the height is 10, and it's really easy to plug in. Okay, well then area must be 1/2 of the length of the base, which is 5, times the height of the triangle, which is 10, right? So in right triangles, again, usually pretty easy to figure out the area of the triangle if you're given that base B and you're given that height H. It becomes more involved when we don't have a right triangle, and that's what we're going to focus on today. So imagine you were given this triangle and you're asked to find its area. Now the equation is still the same, right? Area is still equal to 1/2 of base times height. Nothing changed, but notice I don't really know the height of this triangle. So the base begins here, goes all the way up to here, right? So this is the height of my triangle, H. But I don't really know what that is, and it's going to be hard to figure it out, right? What can I do to use this area equals 1/2 base times height formula to figure out, first of all, I'm trying to figure out the area, but to know that I need to know the height. Well, imagine, so we know our formula, imagine if I just inserted a little line there and I created a right triangle, okay? And notice that the line that I inserted is equal to the height of the triangle. So even though I've now created, you can see this has split my larger triangle into two triangles, right? There's now a triangle over here and another triangle right here. That's fine because it doesn't affect the height of my original triangle, and that's what I'm trying to do. So it's okay to kind of leverage our way and create a new triangle, and I'll show you what I mean. Calling on the information that sine of x, some angle x, is equal to opposite over hypotenuse, here's what I can do. Okay, I know that this angle is 43 degrees. I'm trying to find h, and I know that the hypotenuse measures 8 centimeters. So here's what I can do. I can say, okay, the sine of 43 degrees is equal to my opposite, which is h, over my hypotenuse, which is 8, right? Opposite, h, hypotenuse, 8. So the sine of 43 degrees equals h over 8. If I multiply both sides by 8, I find that h is equal to 8 times the sine of 43 degrees. And then I could just plug that into my calculator and it would give me some numerical value for h. But the point is that that is how I can solve for h. And once I have that, I could plug it into my area equals 1/2, let's see, area equals 1/2 my base, which is 10 times that height that you've just solved for here, right? So that is how we can use our sine function to help us calculate triangle area. Now, you don't want to have to do this step every single time you're trying to find the area of a triangle, right? It's a handy way to do it, but maybe not the most efficient, right? So imagine that every time you have a triangle other than a right triangle, that you have to draw on this line, figure out your sine and do all that stuff. Instead, we have this slightly augmented area formula, which says that area is equal to 1/2 AB sine C. Area is equal to 1/2 AB sine C. Okay, so if you're looking at this diagram, that would be 1/2 of this measure of that length of the triangle, this measure of that side of the triangle, and then the sine of this angle C. Now, what do you notice about the relationship between those two sides and angle C? Well, angle C is the included angle, is an included angle for sides A and B, right? So the point where A and B come together forms angle C. Okay, so again, area equals 1/2 of AB times sine C, or, not using the labels, we can say that the area of a triangle is equal to the measure of two of the sides of the triangle times the sine of the included angle. And let's practice that a couple times and you'll see what I mean. Okay, so here I have this triangle. I'm asked to calculate triangle area. I'm given the length of this side to be 4 centimeters. I know that this side is 6 centimeters, and I know that their included angle is 53 degrees. And what do I mean by included angle? Well, again, I know 4 and I know 6. Imagine they had given us the measure of this angle instead. I wouldn't be able to do this calculation. Because this is not the included angle, right? I would need to know the measure of that side. So I've got two sides of the triangle and their included angle, and I'm going to use my formula, which tells me that area is equal to 1/2 AB sine C. So my A and my B are my sides, okay? And it doesn't matter which one I assign to which because they're just being multiplied together. Sine C, C is your measure of your angle. So this becomes the area of 1/2 times 4, the length of this side, times 6, the length of that side, times sine of 53 degrees. And you just type in 53. Now this setup is the crucial part. Once you get this, it's a matter of typing it into a calculator and hitting enter. And you should get that the area equals 9.58 centimeters squared. Now, a couple things to watch out for with your calculator. You may need to mess around and practice using the sine function on your calculator, whether you're using a handheld one or an internet-based one. Play around with it. Look through the example problems provided for you, either here in this presentation, grab some online, or take some from your course, and just punch the numbers into your calculator and make sure you get the same answers that are expected, because different settings on your calculator could mess with it. Another thing, if you have your calculator set to degrees, which is what we want, you'll get a certain answer. If you have your calculator set to radians, which is just a different unit of measurement that we don't want to use, again, that could affect your outcome. So please play around with your calculator. Make sure your settings are giving you the numbers in the units that we expect. So again, if you type in 1/2 times 4 times 6 times sine 53, you should end up with 9.58, and that's the area of this triangle. Let's look at another one. So notice once again, we're asked to calculate the area of this triangle. We're given this side. We're told that it measures 11 centimeters. We're given this side. It measures 9 centimeters, and their included angle is a measure of 64 degrees. So I have my area equals 1/2 AB sine C equation, and I plug in the information. I plug in the sides 9 and 11 for A and B, and I plug in the angle 64 for C. I plug this into a calculator and simplify, and I find that the area equals 44.49 centimeters squared. Another suggestion I would make when trying to simplify your calculator work, rather than typing in 1/2 times 9 times 11, simplify that first so that you can just punch in one constant times sine 64. Again, the less you're punching into your calculator at once, the less probability of error just from, hitting a wrong key or something like that. All right, let's look at another example. I want to know the area of this triangle. I'm given that this side is 8 centimeters long, this side is 10 centimeters long. They form an angle of 41 degrees. Once again, just plugging in. So my sides 8 and 10 are A and B. 41 degrees gets plugged in for C. I punch that into my calculator, and I get that the area is equal to 26.24 centimeters. Okay. So, brain check here. Let's just say that you were looking at these problems. How would you know whether you have enough information to answer them? In other words, for which of these following questions, which are labeled A, B, C, D, E, F, okay, for which of these is it possible to find the area of the triangle using that method we just used where area equals 1/2 AB sine C? So don't get bogged down in what the actual variables and sides and angles are named. Just notice which ones are given to you. Remember, it has to be two sides of the triangle and their included angle. Two sides of the triangle and their included angle. So let's go through this. We're given side D, we're given side E, and we're given this angle. Is that the included angle? Yes. And so in fact we could solve that triangle given that information. If they told us what D, E, and S were, we could solve using that formula. Let's look at question B. We're given G, F, angle T, and angle U. Could we solve this Well, no, right? Because they didn't give us the included angle, right? So that one couldn't happen. Let's look at the next one. We're given H, I, and V. Well, we were given two sides, but the angle V is not the included angle. This one over here would have been, so we can't do that one either. Next, we're given J, K, and angle W. We couldn't solve this using this information because, again, this would have been our included angle. Having angle W doesn't help us out. Next, we've got side L, side M, and angle X. This is enough information because we've got two sides of the triangle and their included angle. Finally, we've got angle N, or side N, angle Y, angle Z. We already know this couldn't work because we were only given one side of the triangle, not two, so we couldn't even have an included angle because you need two sides to establish that. So this wouldn't work either. So get used to, and the point of this exercise was just to kind of look at the way, what do these triangles look like, and when we're able to solve them using that criteria and when we're not able to. So don't get so bogged down in doing your calculations that you forget to double check, does this triangle look the way it should? Do I have the actual information I need? Okay, don't be tricked into applying this formula where it's not applicable. Now, another way we can use this formula is to find a missing side of a triangle. So let's say I'm given that the measure of this side is 27, that this angle is 15 degrees, and I'm asked to find this other side, side A. Can I still use the area formula to help me out here? Well, yes, because they've provided the area. So I'm still talking about all the same pieces of information, just the ones that have been given to me are a little bit different. So before we were told everything except area, right? We were able to plug in all the variables on the right-hand side of the equation. In this case, we were given area, we were given side B, and we were given C once again, and we're solving for A. So we were given the other three variables. This time we're just manipulating this equation to solve for something slightly different. But I'd still proceed the same way, so I'd still plug in the information I know. So I know that the area of this triangle is 34.9 centimeters squared. I plug that in. I don't know A. I leave it as a variable. But I know that the other side measures 27 centimeters. And I know that the included angle between A and 27, those two sides, is equal to 15 degrees. So I can still plug in the rest, right? From here, I simplify the same way by plugging into a calculator, and once again, I'm really going to stress simplifying and not trying to type everything into your calculator at once. So by that I mean I would maybe do 27 times 1/2, simplify that, right? That would be what, 13.5, so we'd have 34.9 equals A times 13.5 times sine 15. So I would take it down to there, and then maybe I would divide both sides by 13.5. Okay, and then maybe, calculate sine 15, whatever order you want with order of operations. You could have also done this, figured out sine 15 and multiplied it by 13.5. Point being, again, I wouldn't try to do this all in one step. Combine some of your constants together and then get your division happening, move the constants over to the left-hand side of the equation, and you'll be able to solve for A that way, and A comes out to a measure of 9.99 centimeters. Let's look at another example like that. So once again, I'm told the measure of one side of my triangle, an included angle, and I'm asked to find the other side, and I'm given the area to help me out. So using our same equation, area equals 1/2 AB sine C, I plug in what I know. I know that the area is equal to 25 centimeters. I don't know A, I leave it as a variable. I know that side B is 17 centimeters, and I know that, oops, this is incorrect. I know that the included angle is 131. So I would rewrite this 25 equals A times 17 times the sine of 131, 1/2, sorry. obviously errors happening on this slide. So 25 equals 1/2 a times 17 times sine of 131. And in fact, why don't I even pull up, since I have this glitch anyway, why don't I pull up a calculator and we'll just solve this one together. So one web-based calculator that I like to use is called Wolfram Alpha. So let's use this tool to help us solve this problem. So 25 equals 1/2 of a times 17 times sine of 131. Now again, I recommend really not doing all of this at once because that's when you make errors. So I'm going to try to simplify the right-hand side of the equation a little bit. I'm going to take 1/2 times 17. Okay, that's all I'm going to do. 1/2 times 17, and we could probably do this mental math, but just for sake of simplification. So you can see that 1/2 of 17 is equal to 8.5, and that font might be a little bit small, but take my word for it. So maybe the first thing I would do is simplify this, and I'd say, okay, well now I've got it to 25 equals 1/2 of 8.5 times a times the sine of 131. So let's continue simplifying from here. So going back to my calculator, maybe now I'm ready to tackle that sine function. So maybe I type in 8.5 times the sine of 131. Okay, and you can see it's already populated the answer for me. Again, I know it's a little small, but that thing appearing in orange below it is 6.41503. 6.41503. 6.41503. So now my equation has been simplified to 25 equals a times 6.41503. Could obviously divide both sides by 6.41503. Notice that I held on several decimal places. This just makes your answer a little more precise. So a is equal to 25 over 6.41503. Once again, I will pull out my handy dandy web-based calculator to help me with this. And I find that 25 divided by 6.41503 is equal to 3.897. 3.897. Okay, so I know this one was a little messier, but let's review. We were given one side of a triangle, the included angle, and we were asked to solve for the second side. We were also given area. We used our area equation, and we plugged in all the variables we knew, leaving a the only thing we needed to solve for. I started combining things slowly, so the first thing I did was take 1/2 of 17 to simplify those constants, which came out to 8.5. Next I combined my 8.5 and I multiplied it by sine 131. And then I divided both sides of the equation by 6.41503. I simplified that fraction and I found that a is equal to 3.897. Okay. Again, really just a matter of keeping your variables straight and being careful as you take steps through entering things in your calculator. So that was an example of using this formula to find an unknown side. What about if we want to know the angle? So using that same equation, can we solve for the angle? Well, yes. So we still were given area, right? This time we're given a and b. So the only thing we need to figure out is c. So as long as we've got an equation where we know everything except one variable, we should be able to figure it out. So plug in what we know. We know that the area is 12. We know that a and b are 4 and 6.2. Again, you could have written it as 6.2 times 4. That would have been fine as well. And I'm trying to find y, right? That's what they've titled this angle. I'm trying to find angle y. So once again, my recommendation would be to not plug everything in straight away. Simplify your constants first. You should get an answer of 28.94 degrees. Now, another thing, when you get to, in fact, why don't we go through this again? We'll show the calculator again. So let's say you're staring at that and you say, okay, I've got 12 equals 4 times 6.2 times sine y. The first thing I would probably do is take 4 times 6.2. 4 times 6.2 is equal to 24.8. So I would rewrite this and I'd say, okay, 26.8 times sine of y, right? And then the next thing I would do is divide both sides of the equation by that 26.8, so that I have that sine y all by itself. Oh, excuse me, 24.8. So I've got 12, simplifying, I get 0.48387. 0.48387, and again that should have been 24. So I simplified, I did 4 times 6.2, I got 24.8. Then I divide both sides of the equation by 24.8, and I get 0.48387 equals sine y. So at this point, maybe you're wondering, how do I get this y out of here? How do I solve for this? You're going to have to use a function called the arc sine function. And by arc, we mean inverse. So again, depending on your calculator, it might actually be a button that says arc sine. You might have to do some function that includes an inverse button. You might see it written like this with that -1, because that -1 in the exponent means inverse. So again, there are a couple different buttons you might see here. And what you would want to do, is say, what is you're looking to find the arc sine of 0.48387, right? And remember, whatever you do to one side of the equation, you're doing to the other. So what's really happening here is we're taking the inverse of the arc sine of both sides. This side ends up simplifying just to y, and this side simplifies to our answer. So it ends up telling us y equals what? And so for this one, you should get 28.94. So the arc sine of 0.48387 is 28.94. Now again, if you have a wrong setting on your calculator, this may throw off your answer. So if you're uncomfortable using this function, again, you might have to just play around with your calculator, play around with whatever online tool you're using. You saw that I was using Wolfram Alpha, and so in fact, let me show you that. So we're looking for 0.48387. 0.48387. So let me enlarge this. For example, if I'm on Wolfram Alpha and I want to find the arc sine of this, I can actually just type in arc sine of 0.48387 and hit enter. It's kind of like the math version of Google. And you can see if I scroll down, my input is inverse sine, arc sine, of that quantity. I scroll down and it tells me the result in radians. So if you get this answer, 0.50571, that means your calculator is set to radians. You need to set it to degrees. The answer we're looking for in degrees is 28.94, which agrees with what I had here. Okay, let's do one more example of this. I know with the calculator it can be confusing. I promise once you get your calculator handling under control, these calculations will go by really quickly. So we're trying to find the value of x. We've been given that this side measures 8, that side measures 9, and our area is 30 centimeters squared. We're still using that area formula. So we plug in what we know. Once again, the only thing we don't know is the value of x. And once again, I would say don't type something into your calculator that looks like this. Try simplifying first. So maybe you simplify It looks like I lost that half again. Maybe you simplify this first. So let's just keep practicing with Wolfram Alpha. I'm hoping that that will be helpful to you guys. And again, I'll just leave this here for a second in case you want to write it down. The name of the website I'm using is Wolfram Alpha, and you just go to wolframalpha.com. So let's say I want to use this to help me simplify this equation. The first thing I would probably do is simplify the 1/2 times 9 times 8, so that's half of 72, which is 36. So I end up with 30 equals 36 times sine x. The next thing we want to do is divide both sides of the equation by 36. And we end up with 30 over 36 is equal to sine x. I would convert that to a decimal, and then we can find our arcsine. So let's go ahead and do that. 30 over 36 as a decimal, that'd be 5/6, right? So that would be, what, about 0.8 something? Let's look, 0.83. So I've got 0.83 repeating equals sine x. So we're going to use inverse sine on both sides of the equation. This will simplify to x. And then let's type that into Wolfram Alpha once more and see what we get. I'm going to ask it, what is the arcsine of 0.83333333 repeating? And it tells me, once again, it confirms my input, tells me the result in radians, and finally it tells me that my answer is 56.44 degrees. 56.44 degrees. Okay, so one final warning, please be careful with your calculations. You can see even in my presentation, like here I accidentally left off that 1/2 in the formula and I had to write it in myself. That's not a big deal, right? I caught my mistake, but it just shows you how easy it is to either skip a factor in the formula or mislabel something. So always double check your work when you set up the equation. Make sure you compare what you're plugging in to the figure in front of you. Make sure your calculator is set up where it should be. I think that about covers it. Again, that website wolframalpha.com is pretty user-friendly, and I guarantee that once you practice doing these calculations a couple times through, you will master them quickly. All right, I'll see you next time, guys.